You know how it is sometimes you've got these really powerful analytics tools in AWS, but actually getting them to like work together seamlessly, that can feel like a real puzzle.
Oh, absolutely. It's a common challenge.
So today we're diving deep into Amazon Redshift. It's a fantastic data warehouse, no doubt, but we want to explore how to make it truly hum by connecting it effectively with, well, the rest of the AWS ecosystem.
Exactly. We're talking S3, Glue, Kinesis, SageMaker, the whole neighborhood.
The goal here is really about achieving that smooth data flow, getting insights faster. That's the mission for this deep dive.
Couldn't agree more. Redshift on its own is powerful, but its, let's say, potential just explodes when it's tightly integrated. Think of it like an engine needs fuel, needs connections to the wheels.
Nice analogy. So, okay, let's maybe unpack that a bit. Why does this integration really matter? Isn't Redshift good enough by itself for analytics?
Well, it's great for the analysis part, sure. But in any mature cloud data platform, the real magic, the efficiency, it comes from how these specialized services collaborate.
Mm-hmm.
You know,
Right. Each piece doing its job well, but also passing the baton cleanly.
precisely. Redshift needs data, usually prepared data.
Mm-hmm.
S3 is often where it lands. Glue helps transform it. Kinesis brings in the live stuff. SageMaker uses the output for ML if those connections are clunky or inefficient.
You get bottlenecks, wasted compute, slow insights.
All of the above. You get delays, potential failures, higher costs, and just friction. The whole system underperforms. It's not just about Redshift, it's about the platform.
Makes total sense. Okay, so let's get practical. A lot of data starts its journey in S3. What are some best practices for staging data there specifically for Redshift?
Right, good place to start. So think about how Redshift works. It's massively parallel. You want to feed it in a way that lets it use that parallelism,
Meaning
meaning smaller, compressed files, ideally equally sized files too.
equally sized. Why is that?
So Redshift can distribute the loading work evenly across its compute nodes. If you have one massive file and lots of tiny ones, one node gets hammered while others sit idle. It slows things down.
Ah, okay. Balanced workload. Got it. What about compression?
Oh, definitely compress. Use things like gzip or zstandard, reduces storage costs in S3, and crucially, speeds up the data transfer into Redshift because there's less data to move over the network.
Okay, small, equal-ish size, compressed.
Yeah.
What else? Manifest files.
Yes, manifest files are super useful. They basically provide Redshift with a list of specific S3 files to load in a single copy-wide command. It gives you control and consistency, especially if files are arriving incrementally. Avoids accidentally loading the wrong stuff.
Good tip. And file formats. I hear a lot about columnar formats.
Absolutely critical. Use columnar formats like Parquet or Oracy whenever possible, especially if you're also querying data in S3 with Redshift Spectrum,
Why columnar?
because Redshift itself is a columnar database. When you load or query columnar formats, Redshift can often read just the specific columns needed for that query, rather than scanning entire rows. Massive I/O savings, faster queries, it just aligns perfectly.
Okay, so staging in S3, compressed, similar size files, use manifests, and definitely go columnar like Parquet. Got it. Now, moving that data or preparing it, AWS Glue often comes into play, right, for ETL.
Exactly. Glues is your serverless ETL service. When you're building those pipelines to feed Redshift, make sure you're using the AWS Glue connector for Redshift. It's optimized for this specific task.
Better than a generic JDBC connection, I assume?
Much better performance and easier integration generally.
Mm-hmm.
Also, and this is really important, keep your Glue data catalog synchronized with your data, especially if you use Redshift Spectrum.
Remind us, Spectrum lets Redshift query S3 directly.
Correct. But Spectrum relies entirely on the metadata in the Glue data catalog to understand the schema and location of your S3 data. If that catalog is out of date, maybe you added partitions, changed schemas, Spectrum queries will fail or give incorrect results.
So catalog hygiene is key for Spectrum users. Good point. What about real-time data? Kinesis.
Yeah, streaming data is another big integration point. You've got a couple of main paths here. For simpler scenarios, you can use Kinesis Data Firehose. It's a managed service that can capture streaming data and deliver it directly into Redshift. Relatively easy setup.
Nice. And for more complex stuff, maybe transformations on the fly.
Right, if you need more complex processing or transformations before the data hits Redshift, you typically use Kinesis data streams paired with, say, AWS Lambda functions or maybe Glue streaming ETL jobs.
How does that usually work? Stream to Lambda Glue, then?
The common pattern is Kinesis stream dash Lambda or Glue streaming for processing transformation, stage the process data in S3, using those best practices we just discussed, use the Redshift copy Y command to load it from S3.
Ah, so S3 often acts as that interim staging area, even for streaming data after processing.
Often, yes. It provides a durable buffer and allows Redshift to load efficiently using CopyY.
Makes sense. Okay, crucial topic, security. How do we make sure all these connections, S3 to Redshift, Glue to Redshift, etc., are secure?
Top priority, always.
Yeah.
The absolute number one rule. Use IAM roles for service-to-service access. Never, ever embed AWS access keys or secrets directly in your code or ETL scripts.
Right. Grant Redshift an IAM role that allows it to read from specific S3 buckets. Grant Glue a role to interact with Redshift, that kind of thing.
Exactly. Least privilege principle. Give each service only the permissions it absolutely needs to do its job. It dramatically reduces your security risk.
What about network traffic? Should that be going over the public internet?
Ideally, no. For traffic between services within your VPC, like from an EC2 instance running an ETL tool to Redshift or from Lambda to Redshift, you should use VPC endpoints.
Okay, what do those do?
They allow you to connect to AWS services like S3 or Redshift using private IP addresses within your VPC. The traffic never leaves the AWS network backbone. It's more secure, often lower latency too.
Better security, maybe faster performance. Win-win. So IAM roles for permissions, VPC endpoints for private network traffic. Solid advice.
Those are fundamental. Get those right, and you've built a much more secure foundation.
Okay, zooming out a bit. We've talked tech details. For the business leaders listening, what's the real benefit, the payoff of getting this integration right? Why invest the effort?
It really comes down to maximizing the value of your data and your AWS investment. Seamless integration means faster data pipelines. Faster pipelines mean faster insights.
Which leads to quicker, better decisions, presumably.
Exactly. Better decisions, faster reaction times. It also means more robust and reliable processes, fewer pipeline failures, which can be costly, and better, more consistent data governance across the platform. Less risk, higher ROI on AWS.
So faster insights, lower risk, better ROI, pretty compelling. And for the data engineers, the architects, the analysts listening?
For data professionals, mastering these integration patterns is just becoming a core competency. It's not enough anymore to just know Redshift in isolation.
You need to understand the whole ecosystem.
Precisely. Understanding how to efficiently get data into Redshift from various sources, how to secure it, how to connect it to other services like SageMaker for ML that makes you significantly more valuable. It's about understanding Redshift's role within the broader AWS data landscape.
So the clear takeaway here is that Redshift, while powerful, truly shines when it's deeply woven into the fabric of the AWS ecosystem. The synergy is where the real value lies.
That sums it up perfectly. It's about building a cohesive, efficient data platform, not just using individual tools.
So maybe a final thought for everyone listening. Take a moment to consider your own setup. How well are your AWS services, especially around Redshift, actually interconnected? Are there perhaps bottlenecks or opportunities you haven't tapped into yet?
Yeah, are there ways to smooth out that data flow? Could you leverage something like Parquet more or fine-tune your Kinesis ingestion? Exploring those connections could unlock quite a bit more efficiency and speed up those crucial insights. It's definitely worth thinking about.